This video covers the Lesson 2-9 warm-up for Secondary 1 Math, Writing and Interpreting Exponential Equations. The California condor wild population can be described by the function y equals 25 parenthesis 1 plus 0.06 close parenthesis to the xth power. Refer to page 91. Number 1. Is this a growth or decay function? So the first thing we want to do is, if we refer back to page 91 in your notes, you will find that this function that we just read is written in exponential growth form, which is y equals a times 1 plus r raised to the xth power. Now I know this x doesn't look like it's being raised to a power here, but that should be an exponent of x. So, in this situation, is this a growth or decay function? Well, since we have it in this exponential growth form, we know it is growth. The key here is that we're taking 1 and adding the 0.06. Number 2, what is the initial value? Remember, a represents our initial value. So in that same location in our function is 25. So our initial value is 25. Number 3, what is the rate of growth or decay? R. Notice R is located in the parentheses being added to 1, and that would be the 0.06 in the parentheses. So our growth rate, or rate of growth, is 0.06. 4. What is the growth or decay factor? Now remember, our growth or decay factor is represented by B. And to find that, we actually look at what it was replaced with from the general form. So the general form of our exponential function is y equals a times b to the xth power. And so right here, that 1 plus r is our b. So we take 1 plus 0.06, so we get 1.06 for our growth factor. Number 5. If there were 25 condors in the wild in 1982, what would you predict the condor population to be in 2082? Round appropriately. Now, to do this, we want to first think about what's happening. We got 25 condors. That shows up as our initial value, already given in the function. We want to predict the population in 2082. So we went from 1982 to 2082. That would be how many years? Well, that would be 100 years if we were to subtract them. So this is our time, or x. So we're going to substitute it in. So we'll take 25 times 1.06 and raise that to the 100th power. And this is going to give us an estimate of the condor population in 2082. So if we put this into our calculators, it comes out to be 8,483 condors. And those condors are the condors in, right, this is how many in 2082. So we predict 8,483 condors in 2082. Number 6, you invest $5,000 in 2010 in an account where the money grew at 4% per year. How much money will be in the account after X years? Write an equation. First, let's identify the important information in the problem. The first thing we might notice is invested $5,000 in 2010. Then, we also know that the money grew at 4% per year. So there's a key word here that said grew. That means we're dealing with exponential growth. And 4% means we're going to use the exponential growth form. And the exponential growth form is y equals a times 1 plus r raised to the xth power. So to put this into our exponential growth form, we're going to substitute in, and we get y is equal to A, which is our initial amount, our investment, which is $5,000. And then we have it times 1 plus R. Well, R is our 4%. We're going to write it as a decimal. That'd be 0.04. So I'm going to add those together and get 1.04 and raise that to the xth power. This equation represents our situation of investing $5,000 in 2010 at a rate of 4% per year and its growth over time. Well, number 7, what would be the account balance in 2020? Well, we got to think about the time that we were dealing with. In 2010 is when we started. 2020 is when it's coming out. What's the balance? Approximately, rounding appropriately here. So we're going to go ahead and find the difference between 2010 and 2020. Well, that's 10 years. So we're looking at x equaling 10. So we're going to take our equation, the y equals 5,000 times 1.04 and raising that to the 10th power. And if we type this or put this in our calculator, we'll get that we would have $7,401.22 if we round to the nearest cent or penny. So $7,401.22. Number 8. Jamesville has a declining population. In 2015, there are currently 25,000 people in the town. If the population is decreasing by 5% per year, what will be the population after X years? Write an equation. So again, we're going to find our important information. So a few things stand out. We're talking about in 2015, the current population is 25,000 people, and the population is decreasing by 5% per year. So our initial or current would be the 25,000, so this is A. Since the population is decreasing by 5%, that 5 is going to be written as a decimal, 0.05, and this will be our rate of decay, or R. So since it's decreasing again, that's going to be dealing with the rate of decay. And our exponential decay form is y equals a times 1 minus r raised to the xth power. So using this, we're going to substitute in the values we know and write our equation. So we have y is equal to 25,000, because that's our initial value, times 1 minus 0.05. Now if we actually do this and simplify it, we get 0.95, and then we're going to raise that to the xth power. So this equation represents the Jamesville population as it's declining, starting in 2015. Number 9. What would you expect the population to be in 2025? So again, we got to look at our times. We got 2015 going to 2025, and that means that x, or our time, is going to be 10 years, because it's 10 years from 2015 to 2025. And next, we're going to substitute 10 into our equation we wrote in number 8. So we get y is equal to the 25,000 times 0.95 raised to the 10th power. And this will give us our approximate population in 2025. And that population comes out to the nearest person to be 14,968 people. Number 10. What was the population in 1995? Round appropriately. Our equation to represent the declining population of Jamesville is y equals 25,000 times 0.95 raised to the xth power. But this equation was written to start at the time 2015. And we want to know the population in 1995. Well, that means we have to go back in time 20 years. So x, the difference between these two, is 20. But since we're going back in time, we're going to make it a negative 20. So we're going to go ahead and substitute this in. We go y is equal to the 25,000 times 0.95, and we're going to raise it to negative 20th power. When we put this into our calculators and do 25,000 times 0.95, raises it to the negative 20th power, we get 69,737.7. Well, we want to round to the nearest whole person, so we're going to round this up to 69,738 people. And that's how many people would be living in Jamesville in 1995. This concludes the video for Lesson 2-9 warm-up for Secondary 1 Math, writing and interpreting exponential equations.